For those of you who don't know what the biological soil crust is, here are some aspects of it. We have cyanobacteria crusts. We also have crusts with bryophytes and with lichens, depending on the successional steps that will take to form it. The biological soil crusts are composed of these poikilohydric organisms, meaning that they can tolerate extreme variations in water content. They can become completely dry, remaining that state for even several years sometimes, and upon a rain event they can regain their normal metabolism. Also, cyanobacteria produce substances, EPS, extra polymer substances that aggregate soil particles. Even you can see in the crust, I don't know where it is, but it's like like 5 millimeters. It can aggregate and stabilize the soil, so it reduces soil erosion. Also improves water quality because it retains a lot of particles. It can increase water infiltration, reducing surface runoff, and also can increase carbon sequestration because it can photosynthesize. Some bacteria, nitrogen-fixing bacteria, can increase the content of nitrogen in the soil, and also it increases biodiversity. So there is an increase in ecosystem services. So in these crusts, some of these crusts are covered with bryophytes. Some of my colleagues discuss if bryophytes are part of the crust or not. I think they are. So they are, as I told you, desiccation tolerance. They lose almost all water and remain dry and resume normal function when there is an event of rain or when sprinkles some water. Here is the species that is most studied. Syntrichia ruralis is a desert species. It's present all over the world. It's been studied in the United States, in the Mojave Desert. And when it completely dehydrated, it has this look. Very dry, very collapsed leaves, and upon rehydration, I know it's just a copy-paste image, but the result is the same. They regain, they repair any damage that can occur, but they survive, they can endure. So, in my PhD, as Christina told, I studied a completely opposite of that desert moss. This is Fontinalis antipyretica, is an aquatic bryophyte that is very common in the northern hemisphere. And here in the Mediterranean, my colleagues that went to the field and collected noticed something. On the summer, when the streams are very low, there is no water, the bryophyte was completely dried. And when the first rains came in September, October, it resumed its function. It's curious that this bryophyte was considered desiccation intolerant. It would not sustain that mechanism of dehydrating and rehydrating. And if we think a little bit, it would make sense because it's an aquatic bryophyte. It's always in the water. So why did it need to have these mechanisms to tolerate desiccation? But here in the Mediterranean, there is this characteristic that on the summertime they become stranded out of the water. So I studied the physiology, the biochemistry, the molecular mechanisms, and I came to the conclusion that they need time to prepare for desiccation. The Syntrichia has been described to always have the mechanisms present. They are always ready to endure because these cycles go daily, on a daily basis. They become dry when the summer is at the highest peak. They then, on the next morning when dew forms, it rehydrates. When the sun comes up, can photosynthesize a little bit. Then the sun goes higher, they completely dry, and this is over a daily cycle. As this Fontinalis needs to prepare for desiccation, I found out that it only induces these desiccation intolerance mechanisms when it is slowly dry. And also, I'm a bench laboratory scientist. Then Christina took me to the field, and it makes sense because the streams don't dry out overnight. They slowly start to decrease, and they slowly then try the humidity decreases, only very slowly. And this bryophyte adapted to it. So even an aquatic bryophyte that we thought that would not endure, that would not tolerate desiccation tolerance, can in fact have the same mechanisms as a desert moss. At the physiology, biochemically, and molecular biology mechanisms. So, if the mechanisms are similar, it drove me to an hypothesis. Does morphology, because different bryophytes have different morphology, different life forms, does morphology determine tolerance? Because a compact life form can, in fact, allow a slow dehydration and induce protection and repair mechanisms, and in fact induce desiccation tolerance. This is the theme that I'm starting to work on. And what I saw, I did a simple experiment. I took this is also a Mediterranean bryophyte, Pleurochaete squarrosa, from semi-arid areas, and took the shoots, and in fact, the shoots dehydrate exactly the same. This is slow dehydration, this is fast dehydration, and they overlap. The Pleurochaete and the Fontinalis antipyretica, they dehydrate at the same speed when they are isolated, in isolated shoots. But when you look at the colony morphology, what we see is that the different shapes of the colony, in fact, induce different, and we have a large variability on the size of the colony and the shape it takes, because the Pleurochaete squarrosa is like a star, and we have like a very clump that retains water by capillarity. On Fontinalis antipyretica, what happens is when it becomes inside the water, it spreads like a tree, and upon the stream, when it starts to dry, it kind of collapses on top of each other, and the inside of the colony retains humidity and can slowly dehydrate. So it's different. It's a different mechanism. So, looking at our Pleurochaete squarrosa, that is now very interesting to me. I collected in the field, and here it's dry. By the way, it's not the same moss that is circulating. This can then to take a look at the green roof. There's some samples there. This is the extract when it's dry. It's a very dark green, brownish, and when we rehydrate it, upon 1 minute, it opens up. And after 24 hours, it is completely recovered. It shows fluorescence of the chlorophyll at levels equal to any plant that does not have any kind of stress. So it has a very fast recovery. So, how can we use these organisms in the urban restoration context? Got this thinking. Thankfully, Teresa already covered most topics on green roofs. Here is an image I took from the internet. It's a very beautiful building. It's like a spiral that is covered with a green roof in Germany. And here are the services that are. I think you covered. I don't know. You covered the services. Yes. So just to skip it, and some of the services overlap with the services that are provided with biological soil crusts. So here is the Mediterranean climate regions. the Mediterranean, California, Peru, Chile, South Africa and Australia. And as Teresa also talked, we have a very dry summer when water is not available. On other parts of non-Mediterranean climates, water is pretty much always present. Here, the plant vegetation doesn't grow because some of the water is on ice or snow form, so plants do not have access to it. And here in the Mediterranean is when we have most water is on winter time, so it's when plants also grow very well. So this is a problem for the development of green roofs. So we got thinking, can biological soil crusts be used to create a green roof without irrigation? Here is our established in the trays that Teresa already spoke. I collected. We didn't have cultures of the moss, so I collected them from an industrial site that was abandoned, that was growing naturally, and we collected them. We put them on the tray. These little pebbles are. When time goes by, we saw that it was a little bit of problem because it didn't allow to establish the bryophytes, so we tried to remove it as much and just be in contact with the substrate. This is the aspect on the beginning of the rain season, and here is it completely recovered on rain. So it came from here to here. This is not new growth. This is the same moss in July, in September and in October. So we saw that this is the most, I think, most recent pictures. It's also started to spread during the winter, and you can see here that on some spots there are already some cyanobacteria developing that will allow also the moss to spread. So it's like a mutual benefit because also the moss also protects the cyanobacteria, so they can develop, so they can benefit from each other. Teresa already talked about this, and I just want to mention that when bryophytes were associated with native vascular plants, what we saw is that there is an increase in water retention, and plants have a higher performance because we can use they can increase the evapotranspiration, but using the same amount of water. So there is a higher sustainability. Okay. This is just a quick table of a paper where there is the water retention capability of some bryophytes. Here is the water capability when the mosses are soaked wet. Then the mosses over here were plotted dry, just give them removing the extracellular water. And this, for example, these two examples here, we can see that there is 8 to 10 times more extracellular water, so they can have high volumes of water retention. So we also tried other bryophytes on our experiments. Some of them, for example, this one here, without irrigation it doesn't survive, but it survives when associated with native plants. It's also this one. This one also can be used alone, but it also thrives best with association with native plants. So there is we can explore the Mediterranean biodiversity by studying the bryophytes that can be used alone or in association with native plants, and can increase the sustainability of green roofs in the Mediterranean. So, can we have a sustainable green roof in the Mediterranean? Yes, we can. I didn't put Obama there but I like this phrase. If we choose the right species for the right places, and also if Teresa also mentioned this, people like roses and exotics and something, but we have to learn. This is something that we have to learn to appreciate the Mediterranean landscape, its cycles, of yellow, brown, green, and not just importing something that works on other places but not on our climate. So, I want to thank you, and now, during the coffee break, I would like to invite you to our greenish roof, and this is a combination of sedum and our moss that it's having some difficulties spreading because of the substrate. It's very, it's made of brittle, and it's getting, it's not easily spreading, but it's thriving there. So I thank you, and any questions?